All right, let's jump right into it. Welcome to this Masterclass Explainer. I'm absolutely thrilled to have you here today. We are embarking on a journey that's going to take you from the absolute basics all the way to pro-level data modeling in Microsoft's premier analytics tool. You know, as someone who spends literally every single day training analysts to elevate their data game, I can tell you for sure that mastering Power BI is one of the absolute highest ROI skills you can develop right now. So we're going to deconstruct the core concepts you need to stop just making spreadsheets and start engineering true business intelligence.
So here is our roadmap for today's explainer. We'll start off by mapping out the Power BI ecosystem. Then we'll dive right into data prep and modeling. From there, we'll tackle the analytical brain of the software by mastering DAX calculations. Next up is publishing and sharing, and finally, we'll cap the whole thing off with pro performance optimization. Okay, section 1, the Power BI ecosystem. Let's figure out exactly what this tool is and where it lives. Now, when I train analysts, the very first thing I tell them is they have to understand exactly why Power BI is such a massive upgrade over traditional Excel. Look, Excel is fantastic for detailed financial modeling, right? But it relies on single directional relationships and honestly has pretty limited security features for sharing. Power BI, on the other hand, it's built for scale. It gives you bidirectional cross-filtering for highly interactive reports, robust row-level security to really lock down sensitive data, and super flexible connectivity with both import and direct query modes. It's a total game changer. And you've got to notice the strict separation of work within the Power BI universe. You basically have two main environments. Power BI Desktop is your local, free Windows app. Think of it as your construction zone. It's where you connect to data, transform it, and build your actual models and visuals. Power BI Service, though, is the cloud platform. Once your local masterpiece is completely finished, you push it up to the service to share it, build collaborative dashboards, and set up those crucial automated, scheduled data refreshes. Simply put, you build locally, you share globally. Moving on to section 2, data prep and modeling. Now that we know the landscape, let's talk about how we actually get and shape our data. Everything starts in the kitchen, right? And your data kitchen is Power Query. This is your underlying engine for data preparation. The workflow here is simple, but it's incredibly powerful. First, you connect to diverse data sources. We're talking anything from a flat Excel file to SQL servers, SharePoint, or even web APIs. Second, you combine that data by merging or appending different sources together. And finally, you refine it. Using a really powerful language called M-language, you clean out errors, change data types, and filter rows way before that data ever hits your actual model. Now, when combining that data, a pro tip you really need to remember is exactly how these different join types behave in Power Query. This is basically a cheat sheet you'll want to memorize. An inner join only gives you rows that match in both tables, which is great for finding active customers. Left or right outer joins, they keep everything from one side regardless of a match. A full outer join just grabs the whole shebang from both sides. And an anti-join is incredibly useful for finding discrepancies, like, say, identifying customers in your database who haven't actually made a single purchase yet. Okay, so your data is clean. Next, you move into the modeling phase. Here, you have to rigidly organize your data into two distinct types of tables: fact tables and dimension tables. Your fact table is the what happened. It holds your quantitative, numerical, transactional data, like sales amount or quantity. Your dimension table is the who, what, where, and when. It gives you the descriptive context, like the product name or category. And the absolute golden rule here: dimension tables must have unique, non-repeating keys, no exceptions. So how do we stitch this all together? We connect those facts and dimensions using those key columns we just talked about. A one-to-one relationship links a unique row to another unique row. Though honestly, you'd usually just merge those tables anyway. The real bread and butter of Power BI is the one-to-many relationship, linking one unique product dimension to many different sales transactions. And finally, there's the many-to-many relationship. This is a complex linkage used for things like, say, students enrolled in multiple courses, where both tables contain multiple related rows. All right, section 3, mastering DAX calculations. Let's level up here and conquer the analytical brain of Power BI. DAX. It stands for Data Analysis Expressions. This is the absolutely essential formula language you're going to use to extract true business intelligence from your related tables. And while it might look a little bit like standard Excel formulas at first glance, trust me, it is vastly more powerful. It lets you perform highly complex aggregations, dynamic filtering, and sophisticated conditional logic across your entire relational data model. Now listen up, because this right here is a classic interview hurdle for Power BI analyst. You have to understand the critical difference between a calculated column and a measure. A calculated column computes its formula row by row during the initial data load, and the result is permanently stored in your table. It takes up physical space. A measure, however, is calculated dynamically, right on the fly, during query time. It isn't stored in the table, and its result changes instantly depending on the context of the report, like when a user clicks a specific filter. So let me ask you this. When you're building a massive enterprise dataset, which of these two actually performs better in your data model? Take a second and think about it, based on what we just discussed regarding storage and calculation time.
If you said measures, you hit the nail right on the head. Measures are the definitive answer. Because they aren't physically stored in the data model, they use significantly less memory. Calculated columns will literally bloat your file size. By utilizing measures, your reports adapt efficiently to real-time filters and user interactions without bogging down the underlying dataset at all. So always lean towards measures for your aggregations.
And to truly write pro-level DAX measures, you've got to know when to use a simple aggregation versus an iterating function. Take sum and sumAx, for example. Sum is totally straightforward. It just adds up all the values in one single existing column. But sumX, that's an iterator function. It's incredibly flexible because it actually goes through a table row by row, calculates a brand new expression, like multiplying a quantity column by a price column on every single row, and only then does it add up the total results.
Section 4, Publishing and Sharing. So your model is built and your DAX calculations are running perfectly. Let's get it out there. Now it's time to securely share your insights on the Power BI service. But wait, before pushing reports to a collaborative workspace, you really need to think about data governance. Applying row-level security, or RLS, guarantees your sensitive data is perfectly locked down. RLS restricts data access at the row level based on the specific rules you assign to your users. What does that mean? It means a manager in New York opening the exact same report as a manager in London is only going to see the New York sales data. It's brilliant. And when you're designing the actual user experience for your audience, you have to decide exactly how they'll interact with the data. You want to choose slicers for visible, on-page interaction. They're visual elements like drop-downs or buttons sitting right there on the canvas. But choose filters for strict background data control. Filters sit in a side pane and can completely dictate what data is allowed on a specific visual, a single page, or even across the entire report, without taking up any of your valuable visual real estate. Finally, Section 5, Pro Performance Optimization. Let's put that pro-level polish on our work. Listen, a brilliant model is literally useless if it takes 10 minutes to load. I hammer home these 6 optimization rules to all of my students. Number 1, reduce the amount of data loaded. If you don't need a column for analysis, just delete it in Power Query. Number 2, ensure efficient relationships in your data model. Number 3, use aggregations at the source whenever possible. Number 4, simplify your visuals. Too many complex charts on one page will absolutely cripple your rendering time. Number 5, optimize those complex DAX formulas. And number 6, limit direct queries. Import mode is almost always faster. Oh, and use the built-in performance analysis tool to catch any lags before you publish. Wow, we have really climbed the staircase today, taking you all the way from basic queries up to DAX iteration and performance optimization. You now have the exact blueprint you need to elevate your reporting. So it leaves us with one final, provocative question for your analytical journey. Are you ready to stop making simple spreadsheets and start engineering true, secure, and optimized business intelligence? The tools are right there waiting for you. Get into Power BI Desktop, start experimenting, and I will catch you in the next explainer.